Hello guys, let us start today with derivatives of the inverse functions for the 12th standard new syllabus of 2020-21 12th commerce new syllabus. Okay. Now before starting with this chapter, I would suggest this is the fifth part of the chapter, and in case if you have not seen the basics lecture of the derivatives, then please go and check that lecture. I am giving the link of that lecture in the description box. Kindly go check out and then come back for inverse function, because we will need that application of the basics of our derivatives, the definition of derivatives or the definition of differentiation that we have covered over there in our basic lecture. So let's get started guys with the derivative of inverse function. Now in the old syllabus, when we talk about derivatives of inverse function, it was having a lots of concepts of inverse trigonometric functions. Now the best part is that the trigonometric functions have been completely removed. So the inverse function derivative is a very easy part guys. It's really very easy. You just have to apply the basic definition of differentiation and you are ready with your answer. Okay, so let us see how we do this. Come on. If I say y is demand and x is the price of the item, and if I want to find out rate of change of demand with respect to price, then I have to actually find out over here the rate of change of y with respect to x. It means that we have to find out the value of dy by dx, and you all know how to find the value of dy by dx. You just have to differentiate the function with respect to x and you will get the required answer. But in case if x and y are interchanged, say for example in a certain question we come across like this: if x is demand and y is price, still the question remains the same. I have to find out over here rate of change of demand with respect to price. So what is demand in this case guys? It is x. And what is the price? It is y. So when I want to find rate of change of demand with respect to price, I will get the answer as dx by dy. Now what exactly is this dx by dy? Dx by dy is just reciprocal of dy by dx. So when we want to find out the value of dy by dx by dy, sorry, in our given question, what we will do is I will find out dy by dx first, step number 1. Then in order to get the value of dx by dy, we will say over here that this is equal to 1 upon dy by dx. That's a very easy method guys. In order to find the value of dx by dy, I'll shortly explain you this with the help of an example. So the next thing that we do is take a small example. Okay. Let me take a question for you. The question tells us find rate of change of demand, which is x, of a commodity with respect to price y, and I am given the function as y is equal to 18 plus 15x plus 30x square. So as I told you in the beginning, the first step that we will do is we will find the value of dy by dx, and in order to find the value of dy by dx, I will say over here differentiating with respect to x. So when I differentiate this with respect to x, you very well know derivative of y is dy by dx. Derivative of 18 is a constant number, so the derivative is 0. 15x, so 15 into derivative of x, that is 1 because 15 is the coefficient. Again 30 over there is the coefficient, so leave that. Derivative of x square is 2x, so the answer is 30 into 2x. So yes, I get the value of dy by dx is equal to 15 plus 30 into 2, 60x. Now we are interested in the value of rate of change of x with respect to y. It means we have to find the value of dy by dx by dy. So I will say over here rate of change of x with respect to y is equal to dx by dy, which is reciprocal of dy by dx. So when I take the reciprocal of this function, I will get a very simple answer. Dx by dy is equal to 1 upon 15 plus 60x. So that is our required answer. Is that very simple, guys? Yes. So we have to apply the same logic in our exercise second of the derivatives chapter. So guys, you can copy down this, you can pause the video, you can copy down this, and then you can go on with your exercise. Let's start with our exercise. Come on. Exercise 3.2, question number 1. So once again over here the question remains the same. We have to again find out the rate of change of demand with respect to price. So once again let us write down find rate of change of demand x with respect to price y. Sum number 1. Over here I am given y is equal to 12 plus 10x plus 25x square. So this is a very simple sum, guys. We will first say over here differentiate with respect to x. So derivative of y is dy by dx. Derivative of 12 is constant, which is 0. Derivative of 10x is going to be 10. And derivative of 25x square will be 25 into 2x. Just as we did it now. So the answer is 10 plus 50x. This is the value of dy by dx. When we want to find out rate of change of x with respect to y, it means I have to find the value of dx by dy. And what is dx by dy? 1 over dy by dx. So what is the value of dy by dx? The answer is dx by dy is equal to 1 upon 10 plus 50x. So in order to simplify, I can give our final answer as dx by dy is equal to 1 upon 10 into bracket 1 plus 5x. So that's a very simple sum, guys. Question number 1 first sum. Now let us go to question number 1 second sum. Students, in case if you wish to write, you can pause the video, you can copy down, and then you can once again continue with the video. Okay, second sum. You are having over here y is equal to 10x plus log of x minus 4. Sorry, this is 18x plus log of x minus 4. So once again, when we want to find the derivative, we always say differentiate with respect to x. So derivative of y is dy by dx. Derivative of 18x, 18 into 1, that is 18. Log of x minus 4. Now this is a composite function. So that composite function we have covered in our previous lecture, previous video, guys. I'll give the link of that lecture or the video in my description box. Kindly check out that video if you have not seen the composite functions video. Okay, you will get a clear idea of how to find the derivative of composite functions. So I consider this is log of fx, and the derivative of log fx is 1 upon fx into derivative of fx. So this x minus 4 is considered as fx. I have told to you anything other than x is always fx. So basic derivative of log x is 1 upon x. So I get 1 upon fx. And then once again we multiply this with the derivative of the inner function, which is multiplied by the derivative of fx. So when I simplify, I get 1 upon x minus 4 into derivative of x minus 4, which is going to be equal to 18 plus 1 upon x minus 4 into 1 minus 0, because derivative of x is 1, derivative of 4 is 0. Taking LCM, it becomes 18x minus 18 into 4, that will give you 72 plus 1 divided by x minus 4. So I get dy by dx is equal to 18x minus 73 upon x minus 4. Now as we all know that we are interested in the value of rate of change of x with respect to y, which is given by dx by dy. And what is that? It is reciprocal of dy by dx. So I will get over here 1 over dy by dx. So I can say this is equal to 1 upon 18x minus 73 upon x minus 4, which is going to be equal to, therefore dx by dy is equal to x minus 4 upon 18x minus 73. So that completes your value of the dx by dy for the second sum. I hope everybody has understood this sum, guys. In case if you have got any doubt, you can always mail me in my mail on my email. I will definitely help you out with your doubts, guys. Let us see the sum number 3 into this. The question is a similar question once again. Y is equal to 25x plus log of 1 plus x square. So again we will solve it in the same way. We have to say differentiate with respect to x. The derivative of y, as you all know, dy by dx. Derivative of 25x is 25 into 1, which is 25. Again we use the formula for log fx, which we applied in the previous case. So 1 upon 1 plus x square into derivative of 1 plus x square. So in this case 25 remains there, 1 upon 1 plus x square, and derivative of 1, which is 0, derivative of x square, which is 2x. Again we will take LCM like we did in the previous case. So 25 plus 25 x square plus 2x and whole upon 1 plus x square. As we all know that we are interested in the value of rate of change of x, with respect to y, it is given by dx by dy, which is reciprocal of dy by dx. And what is that? It is 1 upon this entire function 25 plus 25x square plus 2x divided by 1 plus x square. So finally when we take the reciprocal, we get over here dx upon dy is equal to 1 plus x square, and when we arrange the terms of denominator in the proper order, it will be 25x square plus 2x plus 25. So guys, that's the required answer for your dx by dy. So that ends our question number 1. Let us start with our question number 2. Question number 2 over there says, find marginal demand where find marginal demand of a commodity whose price is x, and in fact demand is x and the price is y. So how do we get that? If you remember from your 11th standard textbook derivatives, you had a question which was based on this marginal demand, and the marginal demand itself represents rate of change of demand with respect to price, which over here is already dx by dy that we are doing in all the previous sums. So guys, in this sum also, question number 2 also, we have to do the same thing. We just have to find the rate of change of x, but instead of writing rate of change, we will write it as marginal demand. Let us see how we apply that in our first question. You have y is equal to x into e raised to x plus 7. that looks like e raised to minus x. So let us make it minus x. Okay, so now when I have x into e raised to minus x, I consider the first term as u and the second term as v. Because they both are multiplied with each other, we have to apply the multiplication rule over here. So what exactly is the multiplication rule? If y is equal to u into v, dy by dx is equal to v into derivative of u plus u into derivative of v. So when I want to differentiate this, we will say over here differentiating with respect to x. So derivative of y dy by dx, as you already know the rule, it is v into derivative of u. So e raised to minus x into derivative of x plus x into derivative of e raised to minus x and plus 7. So the derivative of 7 is 0. So I get plus 0. So now we get the value e raised to minus x as it is because it is outside the derivative sign. Derivative of x is 1 as you know already, plus this x is as it is because it is outside the derivative sign. Derivative of e raised to minus x is same as e raised to fx because anything other than x is always fx. So minus x is also considered as fx. So I consider the answer as e raised to fx multiplied by derivative of fx. So I will get over here x into e raised to minus x into derivative of minus x. Now you can observe guys, e raised to minus x is a common element over here. So I will get e raised to minus x over here and 1 plus and minus, that will become minus x into 1 because derivative of minus x is minus 1. So we are converting this plus into minus. So that is your value of dy by dx e raised to minus x into 1 minus x. Now when I want to find out the marginal demand, we have to find the value of dx by dy, which is 1 upon dy by dx, which is equal to 1 upon e raised to minus x multiplied by 1 minus x. And we can say that therefore dx by dy is equal to this e raised to minus x. In order to make the power positive, we write it in the numerator e raised to x, and this 1 minus x is left as it is. So I get the answer e raised to x upon 1 minus x. Yes guys, that was our question number 1. It is a long sum. In case you have any doubt, I would suggest go through the entire video carefully, and if you just got it out, just message me and I'll definitely help you. Let us go to the second sum. Y is equal to x plus 2 upon x square plus 1. Once again, when I want to find the derivative, we will say differentiating with respect to x. We consider the numerator as u and the denominator as v. So we get v into derivative of u. Okay, let me write the u by v rule for u. If y is equal to u by v dy by dx, as you already know, v into du by dx minus u into dv by dx upon v square. So here x square plus 1 into derivative of x plus 2 minus x plus 2 into derivative of x square plus 1 and whole upon v square, that is x square plus 1 the whole square. So over here x square plus 1 will remain as it is because it is outside the derivative sign. Derivative of x is 1, derivative of 2 is 0, so 1 plus 0 is going to be 1 minus, we leave this x plus 2 as it is. Derivative of x square is 2x, derivative of 1 is 0, so I am just left out with 2x and the denominator still remains over there, x square plus 1 the whole square. So then when we open the brackets, x square plus 1 is already positive, so not an issue. Minus x into 2x, that will be minus 2x square, minus 2 into 2x, that will be minus 4x. And once again the denominator element has to remain over there, x square plus 1 the whole square. So yes, I get x square positive, negative 2x square, that is negative x square, 1 remains over there, minus 4x also remains over there. So I get x square plus 1 the whole square, that is your required value of dy by dx. But we are interested in the marginal demand. So when we want to find marginal demand, we say it is dx by dy, which is 1 upon dy by dx, and that is nothing but 1 upon this entire term, 1 minus 4x minus x square. I have just rearranged the terms, nothing else, x square plus 1 the whole square. Now take reciprocal of this term, so denominator goes into numerator and my answer is ready, which is dx upon dy is equal to x square plus 1 the whole square divided by 1 minus 4x minus x square. So yes guys, that is our sum number 2 of question number 2. Again a very easy sum. And yes, the last sum of this exercise, sum number 3, which is y is equal to 5x plus 9 upon 2x minus 10. Once again, this is your u value and this is your value of v. So we will be applying the formula for u by v rule when we are differentiating. So I will say over here, differentiate with respect to x. So when I differentiate with respect to x, I get derivative of y as dy by dx. This is equal to v into derivative of u, 2x minus 10 into derivative of 5x plus 9 minus 5x plus 9 into derivative of 2x minus 10 and whole upon v square which gives you 2x minus 10 the whole square. So in such a case, we leave this 2x minus 10 as it is, 5x plus 9. So 5 into x, derivative of 5 is, 5 is as it is, derivative of x is 1 and derivative of 9 is 0. So I get 5 minus 5x plus 9 is as it is, derivative of 2x is 2, derivative of 10 is a 0. So I get just 2. So then denominator remains 2x minus 10 the whole square. So this will become 10x minus 50 minus 10x minus 18. Being very careful with the signs of the second term, guys, it will become plus and minus minus for both the terms. 2x minus 10 the whole square. So guys, you can clearly understand positive 10x and negative 10x will get cancelled off, and I'll get over here minus 68 2x minus 10 the whole square. But we are interested over here in the value of marginal demand, which is nothing but dx by dy, 1 upon dy by dx. So when I take the reciprocal of this, you can directly write the answer that is allowed in your exams. So dx by dy will be negative 2x minus 10 the whole square upon 68. So that finishes your exercise number 2. Quite easily done, right guys? It is so easy exercise. Yes. Thanks a lot for watching, guys. Do like and subscribe our channel. In the next lecture, I will be continuing with the further part of this chapter. Thank you. Take care all of you.